Good morning, Year 8. Today's the 8th of April, 2020. We're now going to move on to 2.2, More Simplifying. So today's title is 2.2, More Simplifying, and the learning intention will be to use the index laws in algebraic calculations and expressions, and to simplify expressions with powers. And in part 1 of this lesson, we're going to be doing questions 1 to 6. So, moving on to the next page. The first question is, what is the value of 3 to the power of 0, 5 to the power of 0, 7 to the power of 1, and 10 to the power of 0? Now, before we do these questions, I thought it'd be helpful if we look at the laws of indices first. There's in total 6 of them, but today we're only going to have a look at 3 or 4 of them. We only need to learn the first 3 laws of indices. So moving on to the next page, we'll come back to these in a minute. Let's just first go through laws of indices. So the laws of indices. Now, indices is another word for powers. So powers and indices basically mean the same thing. Index is the plural. Indices is the plural of index powers. So looking at the laws of indices, so index notation, the index notation is showed to, we use index notation to show repeated multiplication by the same number. So for example, 2 times 2 times 2 times 2 times 2 can be written as 2 to the power of 5. So the little 5 above the 2 is a power or an index. So the 2 is the base, and the 5 is the index or power. And this is read as 2 to the power of 5, or 2 raised to the power of 5. So 2 to the power of 5, as we said, is repeated multiplication. So it's 2 multiplied by 2, multiplied by 2, so it's 5 times, which is 32. So if you see the word evaluate, that means work out, give the value of. So 6 to the power of 2, or 6 squared, is 6 times 6, which is 36. 3 to the power of 4, or 3 raised to the power of 4, is 3 multiplied by 3 multiplied by 3 multiplied by 3, which is 81. And negative 5 cubed, or negative 5 to the power of 3, is negative 5 times negative 5 times negative 5. Now remember, negative 5 times negative 5, they're both negative, so that will be a positive 25. Then multiply the positive 25 with a negative 5 to give you a negative 125. 2 to the power of 7 is again 2 multiplied by itself 7 times, which will be 128. And negative 1 to the power of 5, as we said, is negative 1 times negative 1 times negative 1 times negative 1 to give you a negative 1. Negative 4 to the power of 4 will be 64. So make sure you understand why some of them are negative and why some of them are positive. So when you've got the 2 negatives multiplying each other, that will give you a positive, but when you multiply it again with a negative, that will turn it back into a negative. You can do these questions on your calculators. So for example, to calculate the value of 7 to the power of 4. Now again, depending on the calculator you have, some will have the XY button, some will have a little cat button. So 7 to the power of 4, we will write that as 7, then put the power button in, then key in 4 to give you as 2,401. Make sure you get the same answer, 2,401. Make sure you can work these out on your calculators correctly. Now, the first laws of indices, so this is rule number one, when we multiply two numbers written in index form and with same base, we see an interesting result. So, for example, 3 to the power of 4 times 3 to the power of 2 will give me 3 to the power of 6. 7 to the power of 3 times 7 to the power of 5, which is 7 times multiplied by itself 3 times, multiplied by 7, multiplied by itself 5 times, which will give me 7 to the power of 8. So what do you notice? Well, hopefully what you should have noticed is that when you're multiplying two numbers, which are written in index form, and they have the same base, remember 3 here is a base, and 7 below is the base, you will notice that we basically add the powers. So when we multiply two numbers with same base, the indices, the powers are added. So 3 to the power of 6 is 3 raised to the power of 4 plus a 2. 7 to the power of 8 is, if you remember, the question was 7 to the power of 3 times 7 to the power of 5. That will give us 7 to the power of 8, with 3 plus a 5 is 8. Now, the second laws of indices, when we divide two numbers within index form and with the same base, we can see another interesting result. So, for example, if you had 4 to the power of 5 divided by 4 to the power of 2, so that's 4 to the power of 5, so that's 4 times 4 times 4 times 4 times 4, divided by 4 times 4. So these two pairs of 4s will cancel each other out, leaving you with just 4 times 4 times 4, which will give you 4 to the power of 3. 5 to the power of 6 divided by 5 to the power of 4. So again, if I write this out and do it as a division, again, these 5s will cancel each other out, leaving you with 5 times 5, which is 5 squared. So again, what do you notice? Well, hopefully you should have noticed that when we are dividing two numbers within index form with the same base, we subtract the powers. So when we divide two numbers with the same base, the indices are subtracted. So for example, 4 to the power of 5 divided by 4 to the power of 2 is 4 to the power of 3. So that's a 5 subtracted 2. The second one, 5 to the power of 2 is 6 subtract the 4. Now, when we have 0 indices, so things, numbers raised to the power of 0, which sounds a bit odd, but it actually works. So if I've got 6 to the power of 4 divided by 6 to the power of 4 is 1. Now, if you look at the second laws of indices, the second index law, when we're dividing, we subtract the powers, yes? Well, 4 take away 4 gives us 0, which is 6 to the power of 0. But interestingly, anything to the power of 0 is 1. Because we're saying 6 multiplied by itself 0 times. So the rule is that anything to the power of 0 is 1. So in fact, any number raised to the power of 0 is equal to 1. It could be 10 to the power of 0, 1. 3.52452 raised to the power of 0, 1. 723,538,592 to the power of 0 is still 1. So the third law, if you like, is anything raised to the power of 0 is 1. Now the negative indices, we won't look at that. We'll come back to these later on. But for now, it's sufficient that we've got the first three laws. So when we're multiplying numbers within index form, we add the powers. When we're dividing numbers within an index form, we subtract them. And then the third rule is anything to the power of 0 is 1. So if we go back to our question, what is the value of 3 to the power of 0? Well, it's actually 1. 5 to the power of 0, 1. Now, 7 to the power of 1, well, anything to the power of 1 is actually the number itself. So 7 to the power of 1 is equal to 1. Anything, sorry, is 7. Anything raised to the power of 1 itself is the number itself, which is basically saying what's 7 multiplied by itself once, 7. Now 10 to the power of 0, again, that will be 1. So moving on, we have these questions with exercise 2.2. So write each expression as a single power. So if I do the first question with you, so question 1a, so we've got 3 squared, that's 3 squared times 3 to the power of 3 cubed. Okay, remember, so when you're multiplying two numbers that's got the same bases, we add the power. So that's going to be 3, then 2 plus 5, we're adding the powers, remember, that's going to be 3 to the power of 7. Okay, you do the rest of the questions, and then we'll check the answers in tomorrow's, later on when I post the answers. Now, if we look at the second question, it says simplify. So again, remember, x plus x equals 2x. However, x times x equals x squared. Remember the laws of it, so x times x, so this is basically x to the power of 1 times x to the power of 1. When we're multiplying, we add the powers, don't we? So that's x squared, x to the power of 2. So when we've got 2x squared times, sorry, when we've got 2x times 2x, that's going to give us 2 times 2 is 4, x times x, x squared. That's going to be, let me write this out clearly, 4x squared. Okay, so you guys now try and do question part B and part C. Remember to write out the question, show your workings, and then show your final answer. Double underline to say, this is my final answer. Moving on to question 3, reasoning. So it says simplify. Again, that means write it in its simplest form. So again, if you look at these questions, so the first part is 2 to the power of 4 times 2 to the power of 5. So you know this is your first rule of indices, your first law, add the powers. Here again, you've got the same bases, multiplying, add the powers. Here again, is x to the power of 4 times x to the power of 5. Again, x is the base, so that will stay the same, so that will be x. When we're multiplying, remember, you add the power, so that will be x to the power of 9. So it says, write a rule to explain what you do to indices when you multiply the powers of the same variable. So we know that that's the first rule of indices. So when we multiply two numbers within the index form, you add the powers. Copy and complete. So this is an example I showed you guys before on the PowerPoint. So you should be able to quickly follow that these two cancel each other, these two cancel each other, these two cancel each other, leaving with 2 times 2, which is 2 squared. Now you do the same to the second part of the question. So again, it says, write a rule to explain what you do to indices when you divide the powers of the same variable. Again, so that's the second rule we've learned in the lesson. So that's the second example. Again, you just, like we're showing you with PowerPoint, when you're dividing numbers, they have the same base numbers, you subtract the powers. Now, when you're raising one power to the next, here, so you've got 2 cubed raised to the power of 5. In these kind of questions, you multiply the power. So 2 to the power of 3 raised to the 2 to the power of 5 is actually 2 to the power of 15. When you're raising one power to the next, you don't add them, you multiply them. So again, if it asks you, write a rule to explain, what do you do to indices when you raise a power available to another power? You multiply the powers. Okay, so first one is you add the powers when you're multiplying them. When you're dividing them, you subtract the powers. And when you're raising one power to the next, by another power, you multiply the indices of powers. Moving on to the question 4. So in question 4, it's again simplifying, so write them in the shortest form. So we're saying x to the power of 7 times x to the power of 9 is x to the power of what? By now you should be able to do this quite easily. Z to the power of 12 divided by Z to the power of 4 will be Z to the power of what? Again, remember, you're subtracting the powers and you're just writing the answer there. Here, you've got V to the power of 4 raised to the power of 2. So remember, what do you do when you raise one power by another power? Write the answer there. V to the power of what? And it gives you the hint here of how to do it. Question 5, it says work out the missing power. So again, this is using rules we learned at the beginning of the lesson. So it's saying, for example, y squared times y to the power of what gave you y to the power of 8. So we know when we're multiplying two numbers within the index form, they have the same base, y is the base, y is the base. So ask yourself, well, we know we're going to add these. So we're saying, well, basically 2 plus what gave me 8. So this has got to be 6. So it's going to be y squared, y to the power of 2 times y to the power of 6 will be y 2 plus 6, y to the power of 8. So now you guys try and figure these ones out for part B. This one is division, so it's a subtraction of the powers. And this one is in multiply, so you've got to do the inverse, which is the division. This divided by what? Sorry, this times what gave you the 18 there, not division. So we're saying, okay, this multiplied by this gave you 18. So what number needs to go here? And then finally, question 6 is saying multiply each pair of expressions linked by a line. So you do 3x squared times 5x cubed. You do 3x squared times 2x to the power of 4. You would do 3x squared times 7 to the power of 5, and so forth. So all of these needs to be multiplied by each other to work out all the answers. So we'll stop there for today. We're only doing questions 1 to 6. I know today is the day you have your double lesson in maths, but just use these 2 sessions as one lesson. We're only going to do these 6 questions from 1 to 6 on this day. We're not going to do double maths like we did before. We're going to spend this one lesson for the 2 sessions you have for maths. Any questions, please email me or message me and I'll write back to you, or I can do a one-to-one short Zoom support session with you during the day. Thank you and enjoy the rest of your day.